Hi friends, is my voice is audible to you? If my voice is audible, everything is fine, please let me know. Right? Second, let me have a quick look in the chat. How many of you people are in online so that I will understand. Please say hi so that I will understand like my voice is audible and I am visible to you clearly also. Right? Vasant Sai, hi sir, hi. Hi Vasant Sai, how are you? Hope you are fine. Okay, coming to today's session. Today's session is all about in your previous class because of network connectivity. We are not able to complete the footings. So in this today's session, first of all, we will complete footings, and I will start a new topic today itself called as pre-stressed concrete. In the pre-stressed concrete, today I will talk about introduction to pre-stressed concrete and what are the different types of materials that are used in pre-stressed concrete and different types of pre-stressing that is used. So all these three I will talk, right? So so before I start the session, I just want to say a big hi to all of my brothers and sisters who are on the online, right? How are you guys? Hope you are fine. And there is so much of free content is already happening in this Unacademy learning app. If you are a serious aspirant of GATE or ESE or any other competitive examination, then definitely I can recommend you guys to install this Unacademy learning app. And you can follow me in Unacademy learning app using this link, which is given below. If you type this link, if you press this link, you guys will be redirected to my profile page and you are able to follow me. When you are able to follow me, people will also ask us, sir, what are the advantages? There are three advantages are there, brother, when you are able to follow me. First and foremost advantage, already the free content done by me are free of cost in an academy learning app, you are able to access. Second one, at the end of each and every free session, we are going to provide a free PDF notes to you that you are able to get for free of cost. The upcoming free video lectures of mine will be notified to you. That is the third advantage. So all these three advantages are for free of cost, not even just paying a single penny, right? So, and some people will also ask us, sir, okay, fine. Is there any paid courses are there in an academy learning app? Yes, brother, there are paid courses are also there in an academy learning app. After you install this Unacademy learning app and select your target as GATE and ESE, in the main drop down menu, go to, this is how the main drop down menu will be, go to plus courses. After you go to plus courses in the main drop down menu, you are able to see a terminology or a tab called get subscription. When you press on this get subscription, you are interested in taking the paid course. That means, so get subscription is taking paid course. In paid course, there are two types of paid course. One is plus course and second one is iconic course. So when you had taken this paid course, definitely we are pretty much sure like you will be taught by India's topmost faculty. There is no doubt. One thing. And the lectures will be given to you unlimitedly in the form of live and in the form of recorded version also, even if you are not able to come down to live. This is the second advantage when you are able to when you are able to use this plus course or iconic course when you are able to join for any of the course to join plus course or iconic course to get 10% discount, brother, you are bound to use this code BT10. When you use this code BT10, directly 10% discount will directly come to you on all the courses in an academy plus platform. Some people will say, sir, that is fine. First of this is my first class. First of all, please introduce yourself, right? So let me introduce myself, brother. I am Venkata Tilak. People call me as Venkata sir. Some people call me as Tilak sir. I completed my master's degree from University of Sheffield, England, and about to complete my doctoral degree, PhD also. My background of education is completely into structural engineering. So here also in an academy platform, I am going to teach only structural subjects ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials and management. Previously, I worked as research scientist or research engineer in University of South Carolina for a research funded project. This is in USA. And previously, I worked as head of the Department of Civil Engineering also for in an engineering college called as STEM. This is in Andhra Pradesh. That means both I have experience within inside India and outside of India also. Coming to being a structural design consultant, even till today also, I am working as an independent structural design consultant. I personally give structural drawings to clients, and I personally give material testing reports to my client. This is the work I do being a consultant. Uh, uh, as I have totally 12 years of teaching experience, I have this 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. This is my brief background to that. Some people will say like, sir, is there any paid course? How to subscribe to the paid course? Can you please tell us? Yes, I hope go to Play Store and type this name, Unacademy Learning App. When you type this name, Unacademy Learning App, definitely you are able to download this Unacademy Learning. When you are able to download this Unacademy Learning App, right, I can definitely say like, uh, after you download this Unacademy Learning App, you can follow me by using this link which is given. So after you follow me using this link, in this is the main drop down menu. In the main drop down menu, go to plus courses. After you go to plus courses in the main drop down menu, select your target as GATE and ESE. This is the target or goal, whatever you want to achieve. And after that, you can go to a terminology called as get subscription. When you press on this get subscription, it shows your interest towards the paid course. Now the question is, sir, how the screen will appear like when I had taken this get subscription? When I press on this get subscription, this is how the screen will appear when you press on this get subscription rules. I hope you are able to see this is how the screen is. This is there are two types of courses are there. Are you interested in plus course? Are you interested in icon? So coming to plus codes, or for iconic codes or plus codes, if you want to get 10% discount, here in the referral code, you should type this code called VT10. When you say proceed to pay, definitely the cost of the course will get dropped down to 10 percentage. Drop it down by 10 percentage, not to drop it down by 10 percentage, and you can avail this 10 percentage of it. And I can say one more thing, I can recommend this 12 months course for the students who are in final year. Whereas if you are a student of third year or second year, then definitely I can recommend you guys with this 24 months subscription for third year students and second year students. I just want to convey one more thing. There is no cost EMI is available on 6 months and above subscriptions. So for a subscription duration which are more than 6 months, no cost EMI is also available. So there won't be any problem in terms of payment also, brothers. Now coming to iconic course. Let us suppose if you had taken this iconic, the cost after 10 percentage discount by typing this code VT10 is 45,225 for 12 months duration, right? For any of the course to get 10 percentage discount, don't forget to use this code VT10 and then select you proceed to pay. Some people will say, sir, what are the advantages if I had taken the paid course? There are four advantages are there. Sir. First and foremost advantage is a instant doubt resolution is possible when you had taken the paid course. This is the first and foremost advantage. You can directly chat with the educator and the educator will resolve all your doubt directly through polls. That is the first and foremost advantage. Coming to the second advantage, you will be supported with the test series support also in order to crack any sort of competitive examination. This is the second advantage. So you can write the tests that are provided by Unacademy in terms of mock test, daily wise test, grand test, subject wise test, and you can evaluate at what level you people are when compared to topmost students of Unacademy, and you can definitely improve your performance. That is the second advantage when you have taken the paid course. Coming to the third advantage is all the courses that are provided by Unacademy are completely structured courses. There is no need to plan yourself. We will provide each and every plan. You stick to that plan. If you work out, definitely we are pretty much sure like you are able to get very pretty good rank. There is no doubt at all. And the final advantage when you had taken the paid courses, all the courses that are provided by Unacademy are completely unlimited access is provided. So you will be provided unlimited access to all the courses, either in English courses or Hindi courses within that civil engineering. Maybe the comfort of the device, like by using mobile phone, or maybe by using smartphone, or maybe by using a tab. So depending on your comfort, definitely will be provided with unlimited access. So all these advantages will make you ready to crack any sort of competitive examination in civil engineering comfortably. And some people will say, sir, what is the advantages for iconic course? In iconic course, you will be given with a personalized mentor. The personalized mentor will take care of your track record, and he will assess your performance. After he assess your performance, he will resolve all your doubts also. So that is the greatest advantage when you had taken the iconic course. And the last advantage with respect to iconic course is you will be provided special notes, special PDF notes from an academy. These are the advantage. These are the two extra advantages when you had taken the iconic course. These are some of the topmost indicators directly that we have directly in the app. You can have a look in the app itself also, right? And the courses will be taught separately in English medium and also in Hindi medium. So there won't be any language barrier also. Those guys who are comfortable with English courses, those guys can attend English courses. Those guys who are comfortable with Hindi, those guys can attend Hindi course. And till now in GATE and ESE, so far in civil engineering, we people had launched 8 courses. Out of these 8 courses, few courses are in English, few courses are taught in Hindi, few courses are long-term courses, few courses are short-term courses. When you had taken the paid course, you will be provide access to all the courses that are launched by Unacademy, that are going to be launched by Unacademy within the duration of subscription that you had taken, right? Hi sir, good morning, Neeraj Bhatt. Hi Neeraj Bhatt, how are you? Hope you are fine, right? Right. And I want to convey you every day my class is happening by 11 a.m. in this GATE 2021 rankers batch. You can ask your friends to come and join and avail this free content opportunity also. Right. Last but not least, for you guys, we already started Let's Crack GATE and ESC Civil YouTube channel. So you can subscribe for this channel so that you will not miss even a single content, single video from this platform. And you can say the same thing to your friends so that they will also get motivated and they will also enjoy these free sessions. Okay, right. So for you guys, especially to solve your doubts, we already started a Telegram group. And the name of the Telegram group is the one and same, Let's Crack GATE and ESC, and then the name of another Telegram channel is Unacademy underscore Venkata Tilak. If you come down to this channel by using this link which is given below, you are able to post your doubts and I will take care of your doubts definitely. Dear Neeraj, but it is not good to send my number. It is not at all correct. So you can come down to this Telegram group and we will take care of you. Okay, right. It is against the policy, right? And I just want to convey there is an academic combat exam is also happening for you for free of course. If you are a serious aspirant of GATE or ESA, if you want to track your performance with respect to the topmost students of an academy, I can definitely recommend you to write this an academy combat. So it is a test which consists of 60 questions. So you can write this test. After writing the test, you will evaluate your rank also. So if you write this test, these are in this test, the questions are provided the best questions by the best Unacademy educators all across India. And definitely, we are pretty much sure like you will have so much of fun after cracking those questions. Definitely. Now coming to the questions are definitely engaging to keep the test engaging, challenging, and fun. There is no doubt at all. Now some people will say like, sir, okay, so is there any leaderboard is also there so that after writing each and every question, can we assess at what level we people are? Yes, after writing each and every question, you will track your performance and the leaderboard will show you your rankings just after solving each and every question also, right? And so compete with the best by writing this Unacademy combat, brother. And after you write these examinations, you will be provided with a detailed video solution by topmost indicators. People think like only just a PDF solution is there. In addition to PDF solution, detailed video solution is also provided by India's topmost educators for this Unacademy combat. Right. And after you had written this examination, you can see your rating, you can see your awards or whatever, you can see your score, and you can see your leaderboard also, and so that you can understand at what level you people are when compared to topmost students of an academy. Right. So now coming to the prices. So for, if you are a student for first to third ranks, in such case you will be provided with 3 months free subscription, or you will be provided with Amazon voucher. Either this or this you will be provided when you had got this rank from 1 to 3. When you get the rank from 4 to 15, in such case you will be provided with Amazon voucher. Right. So now the next coming combat is on December 29th. If you want to register for that one, the timing is by 6 p.m. on 29th. So combat will be live. So enroll for free right now itself. And I just, if you want to register now, use this code crackgate. When you use this code crackgate, definitely we are pretty much sure like you are interested to take this examination. Right. These are the prizes that you can win. Right. And coming to the competition format consists of 60 minutes. So 15 questions in four different combats. Totally, I think 60 questions. And the examination will be separately for mechanical, civil, and triple E. So you can write whatever may be the examination, whatever you want to crack, and the relative scoring based on speed and accuracy will be given as the score, and based on this score you will be provided with a rank. So don't forget to enroll now in Unacademy Combat. So use this code crackgate to enroll for this Unacademy Combat. Crackgate. Use this crackgate. Okay, to register for free of cost. Right. So shall we start the session? So coming to the actual today's session, I need to first complete the footings. In your previous class, we started footings, and in this session, first of all, I need to talk. First of all, I will talk about the specifications of footings, and I will talk about different failure modes of footing. Also, I will talk. So coming to the specifications of footing, right? Let me talk about it. Right. Mm. Right. So what is the minimum thickness at the edge of the footing as per IS 456-2000? In order to take care of serviceability, the minimum thickness for the footing, this is the minimum thickness for the footing. In case of sloped footing, the minimum thickness should be 150 millimeter. If I don't provide this 150 millimeter, then there is a problem of durability issues will come. So to take care of serviceability criteria, the minimum thickness that I need to provide is 150 millimeter to satisfy serviceability criteria in case of sloped footings. Now, some people will say, sir, what is the minimum percentage of steel that I need to use in case of RCC footings? In case of RCC footings, what is the minimum percentage of steel? The minimum percentage of steel that I need to use at least is called as distribution steel, which we people call it as temperature steel, which we people call it as nominal steel, distribution steel, temperature steel. Why this minimum steel is provided? This minimum steel is provided to take care of secondary stresses like stresses that are coming because of temperature, stresses that are coming into picture because of creep effect, stresses that are coming into picture because of shrinkage of concrete. All these are all not major stresses, but still they need to be resisted, right? So in order to account for these secondary stresses, I need to provide some minimum percentage of steel. That minimum percentage of steel that I need to provide is nothing but nominal steel or distribution steel. This is provided to meet the nominal requirement against secondary stresses. Example for secondary stresses I can say is uh, temperature stresses, shrinkage of concrete, creep of concrete. These are not major stresses, but still I need to take care, right? Yes. Now some people will come and say, sir, this is fine. Okay. What is the minimum percentage of steel? What is the minimum percentage of steel generally I need to use to take care of the secondary stresses? Some minimum percentage should be used. Na? So coming to that minimum percentage, so as per if it is mild steel, if for mild steel of grade 250, the minimum percentage of reinforcement, minimum nominal reinforcement that I need to use is 0.15 percentage of grass cross section area. So if the grass cross section, the width is B, for example, the effective depth is, the overall depth is D. What is 0.15 percentage of grass cross section area? AG stands for grass cross sectional area. So how you can write about this 0.15 percentage of grass cross section area? 0.15 percentage, 0.15 by 100 into grass cross section area, B into D. This is the class when we are using this mild steel. Let us suppose instead of mild steel, MS stands for mild steel. Instead of mild steel, if the reinforcement, if the steel reinforcement used is HYSD bars, high yield strength deformed bars, high yield strength deformed bars. If I use HYSD bars, in such case, the minimum percentage of steel. So I am talking about minimum percentage of steel reinforcement or nominal reinforcement, which is 0.12 percentage of grass cross section area. So if it is 0.12 percentage of grass cross section area, then in such case I can write as 0.12 percentage, 0.12 by 100 into grass cross section area, which is B into D. So this clause is same for footings and for slab. This clause is same for footings and also for slab. Why this minimum steel is provided? The minimum steel will is provided to distribute the load on a wider area. To distribute the load on a wider area, we require this minimum percentage of steel. Now the question is, some people will come and ask us, sir, okay, that is fine. Some people will come and say like, sir, okay, what is the minimum clear cover I need to provide? So minimum clear cover, coming to the minimum clear cover, why I need to provide this minimum clear cover? In order to take care of different serviceability aspects, so that the concrete shall not, so that the steel shall not corrode, certain minimum clear cover should be provided for different structural elements, right? So minimum clear cover take care of uh, environmental exposure condition. Dear brother, some people are asking to teach in Hindi. Dear brother, I don't know Hindi actually. I am very weak in Hindi, so please excuse me. So the only way that I can teach you is only by English. Right? If you want to say anything in English, you can ask. Right? Right. Once. So if I don't provide this minimum 50 millimeter cover, then what is going to happen in such case? There is if I don't provide minimum clear cover, what is going to happen? Then durability issues will come in concrete. Then uh, durability issues will come in concrete. Some people will also ask us, sir, how this durability aspects will come, like when I don't provide this minimum a clear cover if I don't provide the minimum clear cover. Let us suppose the environment for which this structural element is exposed is severe. In such case, the surrounding aggressive agents can ingress inside the concrete and can attack the core of concrete very easily. In such case, disruption, I mean expansion of concrete will take place. So that will lead to, I can say that will lead to durability issues of concrete. So in order to stop this durability issues of concrete, like I can say, like I can say even this corrosion of concrete, corrosion of steel bars, at least some minimum clear cover I need to provide. Now I hope you understand about this. What is the importance of this minimum clear cover? Now, especially some people will come and say, sir, okay, that is fine. If I had gone for pre-stressed cement concrete footing, sir, uh, plain cement concrete, for example, 1 second. If I had gone for plain cement concrete footing on plain cement concrete footing and it is no reinforcement, plain cement concrete footing. Plain cement. What is plain cement concrete footing? That footing doesn't have any sort of tension still. The footing doesn't have any sort of reinforcement, right? Footing doesn't have any reinforcement. In such case, such type of footings are nothing but plain cement concrete footing. So in case of plain cement concrete footing, generally if this is plain cement concrete, this PCC footing, right? This is the column or this is the wall or column. Beneath this wall or column, this plain cement concrete footing is the supporting this wall, right? If the if the stress that is developed between the soil and the PCC footing is not right, as per the safety, as per IS 456/2000, to achieve safety, to achieve safety in plain cement concrete, if I draw a line from this end to this edge, if I draw a line, the tangent of this angle, which is called, we people call it as tan alpha. This tan alpha should be greater than or equal to zero point 0.9 times of square root of Q naught. How you can work out this Q naught? This Q naught is the load coming from the wall or column is Pu by area of the footing. I can say area of PCC footing, area of PCC footing. So maybe I can write this is maybe I can write this is B definitely, and this length is maybe I can write L. So in such case, Q naught is Pu by B into L. This is how you can work. And for the safety, this 0.9 you know, Q naught you know, FCK. FCK stands for grade of concrete. Grade of concrete, right? So plus one. This is the condition generally that is used for the safety of plain cement concrete footing. This is not for GATE. This is for ESE. This is clearly for ESE. So what is this area of footing in plan? Where AF stands for area of footing in plan, area of footing, area of footing in plan. How we can write? Right? We completed about different specifications of footing. So before I start the session, right, I just want to, before I start the problems on footings, I just want to convey on what ways the footing will fail. The design of footing I will talk. In the design of footing I will talk about uh, design bending moment. We'll talk about design bending moment for which I need to design the section size. Design bending moment, I can say design shear force I will talk. Maybe I can, after design bending moment, design shear force, I may talk about the developing shear stress or nominal developing shear stress. So about these three topics I will talk. Right. Now coming to the design of footing. In design of footing, there are two types of footings are there. One is isolated footing. Second one is I can say footings. There are two types. First one is isolated footing, combined footing. Isolated footing, combined footing. Right. How we can talk about this isolated footing? So when a single column is when a footing is supporting only a single column, in such case such footing is nothing but isolated footing. When is a footing is supporting single column, in such case it is nothing but isolated footing. In case of isolated footing, everybody will say like, sir, how this isolated footing will be designed? Isolated footing design is similar to that of slabs, right? That is designed for bending moment and then checked for shear. So it will be designed for the bending moment, whereas later it is checked for shear. This is how we will do. Now the question is, sir, you mentioned it is designed for bending moment, na? So what is the critical section for bending moment? How to investigate the maximum bending moment in case of this isolated footing, right? In case of this isolated footing. Can I rub the screen first? If you don't mind, I just want to rub the screen first. 1 second, let me drink pail of water. Just let me rub the screen. So coming to the critical section for bending moment. What is the critical section for bending moment in case of isolated footing? What is critical section for bending moment? It is the section at which a bending moment failure we can see, or it is the section at which maximum bending moment is possible. Section which maximum bending moment develops. That is nothing but critical section for bending moment. Now, if you had seen this sketch which is on the left hand side, this is the front view. This is the top view. Top view. These two are top views. Okay, right. Now, if Q naught is the stress from the soil on the isolated footing, Q naught is the stress developed from soil on footing. How you can work out this one? This the load coming from the column on the footing is Pu, so which is Pu by area of the footing in plan. What is the area of footing in plan? Yeah, I can write AF. AF stands for, here I can directly write uh, area of footing in plan. Generally, if you take in plan, this may be the width B, this may be L, right? So the area of footing in plan, generally from this figure we can directly talk as B into N, definitely, right? So we can write Pu by B into, okay, fine. Now the question is, sir, how to work out? This is a just like this is a footing. This is a slab. This is a two-way slab having two-way bending action, right? I can say footing, design of footing or two-way slab bending action directly. as it is having two-way slab bending action. Now the bending moment will be developed with respect to y axis here separately, and here with maximum bending moment is possible with respect to this x axis also separately. Now the question is, sir, what is the maximum bending moment that is developed with respect to this y axis? I just want to convey one thing. Critical section for bending moment is always at the face of column, always at the face of column in case of in case of this isolated footing. Critical section for bending moment it is always at the face of column. Now there are two phases for the column. One is at section YY is one phase for the column. At section XX is at another phase for column. Because this type of bending is two-way type of bending. If you want to show, maybe I can clearly say like this is how this bending can be done. Here the bending is done in this. Here the bending is done in this direction. Now the question is, sir, how to work out the maximum bending moment that is developed with to this y axis? It is very simple, brother. I already mentioned the critical section for bending moment always exists at the face of the column. This is the face of the column. If I take at the face of this column, if I cut the section here clearly, I can take the free body diagram of this left hand side of this section and it or not. This, if I take this free body diagram of left hand side of the section, this Q naught pressure is acting on this hatched area. The area of this hatched portion is nothing but A1I. So what is the bending moment with respect to this YY axis? Q naught into area A1 into, I can directly definitely write, I can definitely write this, one second, I can definitely write clearly, clearly, this is the centroid distance. This point is the centroid distance of this force from this critical section for bending moment. The force itself is area A1 into Q naught. So area A1 into Q naught is the force. Force multiplied by lever arm. Lever arm is X bar. What is this X bar here? X bar we can take this as this. If this distance by 2 is X bar, definitely, right? So this distance from here to here, this distance by 2. Let us suppose this distance is L, then X bar will be definitely L by 2 or something. If this is L1, so X bar is L1 by 2, like that we can write. So similarly, what is the critical section for bend? Critical section, what is the critical bending moment with respect to the XX axis? This is the uh, this is the XX axis. About this XX axis, what is the um, failure bending moment? When the bending action is possible with respect to this XX axis, this way, right? Right. So how you can answer that one? This it is the force acting on this hatched portion. What is the force acting on this hatched portion? It is the stress developed under this hatched portion is Q naught into this area is A2. So I can write Q into area A2 is the compression force acting on this hatched portion. And coming to the centroid distance of this hatched portion from this XX axis. Uh, 1 second. So uh, coming to the centroid distance here, centroid distance of this hatched portion from this x-axis is y bar, right? So Q into Q naught into A2 is the compression force into this y bar is lever arm. So force into lever arm will be the moment, right? Bending moment. So you can work out mx and my. Now the question is, sir, out of these two, what shall be taken as the critical section for bending moment? Out of these two, which one is higher, right? Higher value, higher bending moment shall be take higher bending moment shall be taken as critical section for bending. Critical shall be taken as critical bending moment. Now, shall I move to the next slide, brothers? Neeraj Bhatt or any other person who are on the online, shall I move to the next question? Right, moving to the next question. Some people will say like, yeah, this is how we can work out this bending moment, design bending moment with respect to x-axis or with respect to y-axis. Or people usually call it as critical section for bending moment. Critical section for bending moment is always existing at the face of the column. This is the column now. So at the face of the column here or at the face of the column here, in these two places only the critical section for bending moment exists. Right now the question is, sir, okay, we had designed the for the maximum bending moment we can design the section size. Now for everybody will say like, sir, how we can design the section size for maximum bending moment? So I hope you know maximum the section size for which we can design the bending moment is mu limit, we can write it as 0.138 fck b into d square, something we can write na. B is 1000 and from that one d required is square root of mu limit by 0.138 fck into b. So using this equation we can fix the depth. So we try to fix the depth more than this depth such that it is safe in terms of section size generally. Now, after fixing the dimensions, what is the question is, sir, how to check for shear, sir? That is the question. So you already know, like in case of footings, it is just like the footing design. Footing design is designed just like that for designed for bending, and checked for shear. We had designed for bending, right? We had already designed for bending the section size. After we had designed for this bending, this depth required. After this depth required is over, we can work out AST required based on taking it as under reinforced section, right? And after that one I need to check whether the section is safe in terms of shear or not. Now the question is, hmm, okay, how to check for shear, right? uh, in shear there are two types of shear failures are there. One is one way shear or pure one way shear, or people call it as beam shear. Second type of shear is two-way shear or punching shear. Let me discriminate what is the difference between one way shear and two-way shear. Now I just want to take, this is the column, this is column. From the column, this is the footing, the load coming from the column on the footing is pu, for example, and this is the tension zone of the footing. So the reinforcement is provided on the tension side. Okay, fine. This is how the reinforcement is provided. Now the question is, this is the width of the footing is b and the length of the footing is, for example, it is l. Now what is this critical section for one way shear? One way, another name for one way shear is also called as beam shear. That means shear crack is able to propagate only in one direction, in one width direction of the footing. In such case, such type of shear is nothing but one way shear. Example here is, if you take, this is q naught. This q naught is uh, stress developed from soil on footing due to load P. is equal to Pu by 3 into L. This is how we can work out. Okay. Now the question is, now because of this load was has got applied here, this is how. This is in front. This is in front view. This is in top view. This is in front view. This is in top view. Now in this front view, if you see, uh, from the face of the column here, the shear crack will happen at an angle of 45 degrees from the face of the column, definitely. So if you take from the face of the column here, uh-huh, this is how the crack will get started. This is how the crack will get started. This is in top view. This is in front view. So critical section for one-way shear, where this critical section for one-way shear is possible. Critical section for one-way shear is possible at a distance of d from the face of the column. This is the face of the column. This is the uh, face of the column. From the face of the column, critical section for one-way shear will occur at a distance of small d, effective depth d, from the face of the column, right? So if you take, why this is happening, this type of one-way shear failure is here. This is a shear crack, definitely, and the shear crack is happening at this section at a distance of d from the face of the column. This is the face of the column. So from the face of the column at a distance of d. Okay, now due to this excessive shear, how the crack will get originate, brother? Due to this excessive shear, a crack along short direction develops at a distance of d from the face of the column. So this crack is developing along shorter direction. This is shorter direction. Mhm. Shorter direction. So the shear failure is happening along shorter direction, but not along longer direction. What is this one means? Let me show you. Is the longer direction, right? So due to this excessive shear, a crack along short direction will develop. A crack clearly along this short direction will develop at a distance of d from the face of the column. Right. So now people will say like, sir, why always at a distance of d, brother? Dear brothers, the crack of shear will happen at an angle of 45 degrees. So from this, if the crack will start originate, this crack will propagate at an angle of 45 degrees. It is already d, na? So in such case, if this is already d, then obviously this angle is 45 degrees. Angle is definitely, the angle is 45 degrees, right? This is how the crack will get developed, right? Now coming to, what is the name of that shear force? It is, the name of that shear force is one-way shear force. How you can investigate that one-way shear force, brother? That one-way shear force you can investigate by using this formula Q naught into A3. Now everybody had a doubt like, what is this A3, sir? That is the question. A3 is the hatched portion. How you can mention this A3, brother? A3 is this length. This maybe small b, for example, right? So this A3, how you can write this A3? A3 is the area of this hatched portion. This length is already L. From that L, I need to remove this width B, right? So L minus B, I need to remove. L minus B minus D. Uh, I can L minus B. I can write this value. I need to work out this hatched portion value. I need to work out. I hope you are able to work out this hatched portion value is how much easily. This from this L, I need to remove this B, and from L minus B, B minus D. This is how we can work. I hope you can clearly work out easily this width from here to here. What is this width, right? This width we can work out, and this A3 is equal to B times of this much. So maybe if I want to show you, this is, so A3 I can write as B times of L1. Is how we can work. Now coming to this one-way shear force, how you can work out this one-way shear force? To investigate this one-way shear force, you can take the free body diagram of this cut section here. Cut section is XX, and you can take the free body diagram of left hand side of this cut section, and you take the free body diagram of left hand side of cut section XX. VU is equal to, this is Q naught into area A3. So coming to area A3 also you know. And now coming to nominal or average one way shear stress. One way shear stress. Nominal or average one-way shear stress is equal to, the shear failure is VU by the shear stress is developing on what section. See here, the shear stress is developing on, see here, to take if you take the free body diagram of this section to the left hand side, you take the free body diagram of section to the left hand side, then definitely this is how the section free body section, and this is how this pressure is. When you take this as Q naught, Q naught, this is acting over what width? This is Q naught into A3. This is the force that is coming up, whereas this is resisted by this this is resisted by the force at this section, and this section, this shear force is VU. So this VU is equal to Q naught times of A3. Now the question is, sir, we know this VU, which we people call it as nominal or average one-way shear stress. Okay, fine. How to find out this? This is the shear force. The shear force is acting on this area. Hope you are able to see on this area. What is this area? This hatched area. This width is already B. Is already B. Right? This depth is effective depth DC, right? So this shear force VU is acting on an area of this hatched portion B times of DC, right? So one way or average or nominal one way shear stress. The nominal or average one way shear stress is equal to shear force, which is VU by this area is B times of DC. What this DC stands for? Depth of the, I hope clearly you are able to see here. DC stands for, DC stands for here, depth of the section. DC stands for depth of, oh, I mean, effective depth of footing at the critical section for one way here, right? So if this is the case, which is BU by B times of DC, Yesterday's problem request. Dear brother, dear Jalani, I am going to talk about that one only. I am not going anywhere. So please, yesterday I didn't discuss any problems. So please excuse me. So today only we will do. Okay. So please wait. The problems will come. Okay. Right. This is how you can work out nominal or one-way shear stress. Now some people will come and say like, sir, how to investigate this? This is how you can see one-way shear failure is always possible from the face of the column at a distance of at a distance of effective depth from the face of the column. This is how clearly we had already mentioned. Second type of shear failure is two-way shear failure. Another name for this two-way shear failure is called as punching shear failure. Two-way shear failure we can say. Please, dear Jelani, please let me complete this one. So I doesn't have so many hands to complete all the things at a time. Okay. So please excuse me, one by one, bit by bit, bit by bit, I will complete each and everything. Okay, please. Now we had completed one-way shear. How to work out the two-way shear or punching shear? This is now when you had taken this as a slab, for example, right? This has got sufficient length, has got sufficient width. Now this two-way shear is nothing but punching shear. This type of punching shear types of failures you might have seen in the flat slabs. You see flat slabs, slab which doesn't have slabs directly resting on columns are directly called as flat slabs. In case of flat slabs, slabs directly resting on some flat slab, right? In case of flat slab, the major failure is by punching shear failure. Major failure is by punching shear failure. Mhm. Major failure is by punching shear. What is this punching shear failure? Shear failure taking place in along longer direction and shorter direction, longer direction and shorter direction of the footing in plan. In such case, such type of failure is shear failure is nothing but punching shear failure. So let me write that. When a failure takes place along longer side and shorter side, when a shear failure takes place along the longer side and shorter side of a footing in plan. In such case, such type of failure is nothing but punching shear failure. I hope you clearly you are able to see, dear Jelani Basha or any other person. Here, the failure of shear is happening along in this direction and along in this direction. Both along longer direction, both along shorter direction. In both the directions, the failure has taken place. So that's the reason why we can mention this type of failure is called as punching shear failure. Right? Right? Now the question is, sir, where 1 second, brother. Sorry, brothers. Okay. So here I just want to say, in this two-way shear or punching shear failure, the shear crack will originate in both the directions, in shorter direction and also in longitudinal direction in plan, in this way. If this is how the load is acting, now because of this load, this fracture will happen from the face of the column at a distance of d by 2 from the face of the column. This is the face of the column. The fracture will happen at a distance of d by 2. I hope you are able to see from this face of the column. This will happen at a distance of d by 2. From this face of the column, fracture will happen at a distance of d. From the face of the column, the fracture will happen at a distance of d. So here you are able to see this is the critical section for two-way shear failure. This is the critical section for two-way shear failure. What this D stands for? D stands for effective depth of the footing at the face of the column. Where D stands for oh, effective depth of footing. The D stands for effective depth of footing at the face of the column. Now, what is so as per IS 456, the failure for two-way shear or punching shear will happen at a distance of d by 2 from the face of the. I hope you can see this is the section. This is the fracture line. Clearly, you are able. This is the fracture line. Now, some people will come and ask us, sir, how to work out that two-way shear, sir, two-way shear failure. What is the magnitude of that two-way shear failure? If VU is that punching shear, if VU is punching shear, then definitely I can work out it as Q naught. What is this Q naught? Definitely Q naught stands for the stress from the soil on the footing, which is Pu by, I can write as area of foundation in plan, A of area of foundation, right? This is what is Q naught. Q naught multiplied by this A4. What is this A4 here, brother? This A4 clearly we can say like A4 is the area of the hatched portion in plan. This is the area of the hatched portion in plan. Clearly you are able to see. What is this area of the hatched portion in plan? So which is the bigger rectangle area minus area of this fracture line in plan. I hope clearly the area of the fracture line in plan. This from this area, if I remove this area, then I will get this A4, na? Right? Isn't it or not? So shall I work out this A4? How we can work out this A4? From the bigger rectangle, let me show. This bigger rectangle, if I remove this area of this smaller rectangle, then the area will be the area of the hatched ones, right? The area of the hatched one is nothing but A4. Now coming to this A4, how you can work out, you can easily work out A4 easily. Now coming to the nominal shear stress. Nominal shear stress, what is the name for this nominal shear stress? Nominal two-way shear stress. Nominal or average, nominal or average two-way shear stress. Nominal or average two-way shear stress by workout. If tau v is a nominal shear stress, or average two-way shear stress. Nominal shear force, which is Bu by that shear force is developed, the shear stress is developed on this area, on this hatched area, clearly on this hatched area. What is this hatched area? This area, this is nothing but perimeter of the fracture, perimeter of the fracture line. So I can write tau v is equal to v by this hatched portion area. The hatched portion area is perimeter of fracture line p multiplied by the effective depth of the section at critical section, which we people call it as dc, right? So where p stands for perimeter of fracture line, where p stands for perimeter of fracture line. So using this concept, you are able to work out either two-way shear force, and also you can work out a nominal two-way shear stress, nominal shear stress or two-way or average two-way shear stress. So, and before I start the problems, for masonry wall footings, where the critical section for bending moment is possible. For masonry wall footings, critical section for bending moment is halfway between center line and the edge of the wall. This is the center line, and this is the edge of the wall. In between, halfway between middle way between the center line and edge of the wall for footings under masonry wall. So this is a masonry wall. This is an RCC footing, or maybe a plain cement concrete footing, anything. The footing which is below the masonry wall. In this case, in the above case, critical section for one-way shear and two-way shear is same as that of an RCC column resting over RCC footing. So critical section for one-way shear, two-way shear is one and same. There is no change at all, just like that of RCC footings. So moving to the problems. I hope the problems has came down. Now it's your duty to solve the problems. Of course, to support you, I will also solve. I hope you are able to see these problems, right? Right? A square pad type footing. Square pad type footing, okay, 3.5 meter in size is designed to support a square column. Okay, a square pad footing is there. You take a square pad footing, 3 point square pad footing means its length is equal to breadth, both are 3.5. It is designed to support a square column. It is designed to support a square column of 400 millimeters. Okay, a square column is resting at the mid. Okay. And the size of the column is 0.4 meter by zero point 0.4. Safe bearing pressure below the footing, which we people call it as Q naught. Safe bearing pressure below the footing is 122.4 kilopascal. सर अमन खा रहे सर बीसी पुल में कैसे रहता है बीसी पुल में ठीक है भाई every book is good brother, not at all a problem, but every book was written only from IS codes. Okay, please be aware of that. PC Purmiya is good, right? So Q naught is equal to, okay, they had mentioned for one-way shear, okay, design shear force and nominal shear stress. So what is the design one-way shear force they are expecting? So what's the question is, they are expecting what is the design one-way shear force. People will call it as U. U is equal to design one-way shear force. How you can investigate this one, dear brother? This one-way shear force, one-way shear force is always possible from the face of the column at a distance of effective depth d from the face of the column, right? So if I take, if this is the face of the column, If this is acting at a distance of base of the column D, this is the critical section for one way. Here I can write. Maybe I can write this as this as 3 meter. This is critical section for one way shear. I'm expecting answer from you guys. What is the one way design shear force? What is the one way design shear force? So VU, this one way design shear force, VU is equal to Q naught times of this. This is this hatched portion is A. I just want Q naught. How much is this Q naught, brother? Q naught is 122.4 kilopascal. So I can write as kilonewton per meter square into area A. What is this area A? Area A is equal to L times of this 3.5. What is this L, brother? L stands for, this is 3.5 minus 0.4. 3.5 minus 0.4 by 2 minus effective depth D, right? So which is 3.5 minus 0.4 by 2 minus effective depth D. What is this effective depth D from the face of the column? So effective depth of the footing is 560 millimeters. So which we can write it as 0.56. Is that okay? Right? If you work out this, definitely this answer for this L, definitely this answer for this L will be 0.99 meter, right? So this area A, how you can write this one? 3 point, this hatched portion is 3.5 meter into L. So 3.5 meter into L, it is 0.99 meter. So if you work out this one, this answer will be definitely 424.116 kilonewton. This is the answer for one way shear force, design one way shear. Now this first thing is one way shear force, design shear force is over. They are expecting second question. The second question is nominal shear stress. What is this value of this nominal shear stress that they are expecting? So can you work out the nominal shear stress, brother? Yes. Maybe this is first question. So second question. So can I rub the screen? So before I rub the screen, nominal or average one way shear stress. How you can work out? This is nominal or average one way shear stress is du by. We can write this. This one way shear failure is happening on this critical section. This is critical section. Section for one way shear, right? So can I work out that one as du by, this is acting over what width, brother? This is acting over a width of 3.5 and it is acting over a depth of effective depth d, right? So I can write vu by b times of d. This I had already given formula in your previous slides. Formula your previous. What is that value of this VU? 424.116 by B. B is 3.5 meter and effective depth at critical section. What is DC? Effective depth critical section for one way here. So what is that DC? DC is 0.56 meter. If you work out this one, which is definitely 216.38 kilonewton per meter square. So if I want to write in terms of megapascal, I can write it as 0.216 megapascal. Megapascal is Newton per meter. 0.216 mega is how I can write. So if you see this option that is matching is 0.216 megapascal 425. 425 or 424 or 425. I hope clearly you are able to see point 424.116 answer in kilonewton, and stress is 0.22 megapascal. Correct option is B for Boston itself is the correct option. Is that okay? So shall I move to the next question? Right, moving to the next question. I hope you are able to see this. A square pad type footing 3.5 meter in size is designed to support a square column of 400 millimeters. A square pad type footing 3.5 meter. Same problem. Problem data is one and same. But the question that was asked from the data is different. Is designed to support a square column of 400 millimeters. Okay, there is a square column is there of size 400 millimeters. 400 millimeters is 0.4 meter, zero point 0.4. The effective depth of the footing. The effective depth of the footing is 560 millimeter, which is 0.56 meter. Okay. The safe bearing pressure below the footing is, which we people call it as Q naught. Q naught is 122.4 kilopascal. Kilopascal is kilonewton per meter square, right? Based on ultimate load. For two-way shear, they are expecting two-way shear force, design shear force. If VU is the design shear force for two-way design shear force. VU design way, that is the question. And nominal shearing stress, and they are expecting tau V, the nominal shear, two-way shear stress. Nominal two-way shear stress. Okay. So coming to this VU, if you see the critical section for punching shear or two-way shear is possible at a distance of d by 2 from the face of the column. So if I take from this face of the column, another column, this is the section where two-way shear failure is possible, you can say. From the face of the column, this is happening at a distance of d by 2, a distance of d by 2, d by 2 from the face of the column, right? This I can say a two-way shear failure. Now coming to this two-way shear force, how to work out this VU? VU is equal to Q naught multiplied by area of this hatched portion, area of this hatched portion, right? So if I want to write this, VU is equal to design shear force equal to Q naught times of A. Q naught is how much? It is 122.4 kilonewton per meter square into area A. A. A stands for area of the hatched portion shown, which is in blue, which is in green. Area of hatched. area of hatched portion shown in green, right? Yeah. Now, can you work out what is this area of this hatched portion, brother, which is shown in greening? I can say bigger rectangle minus smaller rectangle dimension. What is this dimension? This is zero point 0.4. This is d by 2. 0.56 by 2 plus 0.56 by 2. This is 0.4 plus 0.56. And this is also zero point 0.4 plus 0.56. This is how we can try. Now, coming to this shear force VU, two-way shear force. How you can write this two-way shear force? Design two-way shear force, which is equal to VU is equal to Q naught multiplied by times of A, which is 122.4 into area A. Area A. So area A, I can write bigger rectangle minus the smaller rectangle. Now obviously I'm going to 3.5 square minus 0.4 plus 0.56. 0.5 square minus 0.4, 0.56. If I do this one, definitely I'm going to get this value of this B. This is 122.4 kilonewton per meter square. This area, if you work, this will be definitely 11.3284 meter square. So this answer will be 1386.596 kilo. We can work out. This is two-way shear force. Okay. Now the question is, some people will come and ask us, sir, after this two-way shear force, how you can work out this another terminology called as uh, um, nominal shear stress, two-way nominal two-way shear stress. Nominal two-way shear stress. So coming to this nominal two-way shear stress, we can directly write it as du by perimeter of fracture line into depth of footing at critical section, where P stands for perimeter of fracture line, right? So if you see what is this VU, 1386.596 kilonewton, we can write divided by the perimeter of this fracture line. What is this perimeter of this fracture line, brother? So clearly you are able to see this is the perimeter of the fracture. What is this perimeter of this fracture line? Zero point 0.4 plus 0.45, 0.4 plus 0.56. How many dimensions are there? 1, 2, 3, 4. Right? So directly I can write here by 4 times of 0 0.4 plus 0.56. Perimeter of fracture line into uh, depth of the footing, effective depth of footing at critical section. What is the effective depth of footing at critical section? Is 0.56 meter, right? So if you work out, definitely this answer will, this is in meters. So it is kilonewton per meter square. Kilonewton per meter square means kilopascal. I can write it as 640.8 kilopascal. In other words, I can write the same answer as 0.644 megapascal Newton per millimeter, right? So I can say like 0.644. The answer for VU is 13686.64. So the correct option is, directly you can pick option C itself is the correct option. Is that okay? Can I move to the next question? Right. Moving to the next question. I hope you are able to see this next question. Na? A square pad type footing 3.5 meter in size is designed to support a square column of 400 millimeter size. Okay. The effective depth of the footing is 560 millimeter. Okay. Same question. Question is not changed. But the data is one and same, but the question what they are expecting you to find out, that data has got changed. This 3.5 meter, 3.5 meter, protect column of zero point 0.4 meter, zero point 0.4 meter. The effective depth of footing is 56 millimeter, 0.56 meter. Safe bearing pressure below the footing is 122.4 ask kilonewton. The design bending moment. Design bending moment. So if you take what is the design bending moment, design bending moment is possible either with respect to x axis or with respect to y axis, whichever is high I need to consider. So with respect to x axis, if we call it as mx, maximum bending moment that is developed with respect to x. Mx is equal to, here it is a square type of footing. Mx is equal to my is equal to q naught times of area into x bar. Coming to x bar, I just want to say this is x bar. Q naught into a into, what is this q naught? Q naught we can work out it as 122.4 kilonewton per, and area of the hatched portion. What is this area of this hatched portion, brother? The area of this hatched portion is definitely this much. It is how much? Is 3.5 minus 0.452. So I can write directly as into area 3.5 minus 0.42 into this width. This width is already 3.5, right? Into x bar. X bar is how much is x bar? 3.5 minus 0.45. This is, you can see like this is area A. This is x bar. If you do this one, definitely you are going to end up with this answer 514.615 kilonewton meter. This is the bending moment with respect to x axis or y axis, because it is a square type of footing or pad type of footing. In this case, maximum bending moment possible with x axis or with respect to y. Design bending moment is one and same, right? So directly I can pick like option A itself is the correct option. Is that okay? Right? Shall I move to the next question? Moving to the next question. I hope you are able to see the next question. A concrete column carries an axial load of, a concrete column carries an axial load of 450 kilonewton. Concrete, take a concrete column, carries an axial and a bending moment of 60 kilonewton meter at its. There is an isolated footing of 2 meter by 3 meter with the 3 meter side along the plane of bending. So an isolated footing of dimension 2 meter by 3 meter. Okay, they are saying this is how the footing is, and the moment is acting perpendicular to this 3 meter side. So this is 3 meter, is 3 meter, whereas this is 2 meter. That's what the question. An isolated footing of 2 meter by 3 meter. The 3 meter side along the plane of bending moment is provided under the column. Okay, is provided under the column. Okay, this is the thing. Let me show. There is a is acting. At moment is 60 Newton meter. Okay, CG of the column and footing coincides. CG of this is the column and the CG of the footing both are coinciding. And CG of the column and the footing are coinciding, then they are expecting net maximum and minimum pressure in kilonewton per meter square on soil under the footing are respective. So they are expecting maximum stress and minimum. So when they are expecting maximum stress, sigma max is equal to P by A plus M by Z. Minimum stress, sigma minimum, is P by A minus M by Z. If you are able to substitute these concepts of result total stress correctly, the problem is over. Now to answer this one, right, let me take another slide. Is that okay? I'm taking another slide for you guys. Sigma max P by A. So P is for P by A plus M by Z. P is how much, brother? 450 kilonewton. It is acting on what area? It is acting on an area of 2 meter by 3 meter. So 2 by 3 square meter plus moment. Moment is, I hope, what is that moment that was provided? The moment that was provided is 60, right? There is no essentially directly a physical moment is there, which is 60 kilonewton meter. So I can write 60 kilonewton meter by Z. Z is BD square by 6. So BD square by 6 is B is 2 BD square by 6. Right? This is about plus and minus. So I can write sigma max comma sigma minimum. We can write. If I take plus sigma max will be 95. I can write kilonewton per meter. Sigma minimum I can take when here if I take minus I will get sigma minimum. If it is 55 kilopascal kilonewton per meter. How we can get the maximum and minimum stresses at the bottom are, so at the bottom here I can say sigma max. This is sigma max. This is sigma max, right? So the answers are 95 and 55. Correct option that is matching with our options are option A, right? Can I move to the next question? Moving to the next question. An RCC square footing of 2 meter length, square footing of 2 meter length and uniform effective depth of, so they are saying it's square footing of length. Oh, 2 meters. Okay. is provided for 3 meter by 3 meter 300 millimeter by 300 millimeter column. The line of action of compression load passes throughout the centroid of the footing as well as of column. Line of action passes through the footing and passes through the CG of the column also. If the magnitude of the load is if PU 320 kilonewton, the nominal transverse one-way shear stress in the footing. They are expecting what is one-way shear stress here. So to work out this one-way shear stress, first of all, I need to work out Q naught. Q naught is PU by L into B. So it is 320 by 2 by 2. The answer is 80 kilonewton per meter square. Is Q naught. They are expecting one-way shear stress. To calculate this one-way shear stress, how we can calculate? Uh, to calculate one-way shear stress, calculate this one-way shear stress like the one-way shear stress is always possible from the face of the column at a distance d from the face of the column, right? At a distance d from the is the critical section for one-way shear. One-way shear. Now to calculate that one-way shear stress, which is one-way shear stress, which we called as tau v is equal to v by, we can write like this is b. We can b. So how you can work out this vu? Vu is equal to Q naught multiplied by this hatched portion area A. Q naught into A. Q naught is 80 kilonewton per meter square into area A. What is this area A, brother? This area A, you can write this one as 2 meter multiplied. From this one, 2 minus, it is 0.3. 2 minus 0.3 by 2 minus effective depth. Effective depth is 200 millimeter, na? So minus 0.2. If I do this one, definitely this answer of VU you are going to get or end up with 104 kilonewton. And this VU is 104 kilonewton. 104 kilonewton divided by B. B is 2 meter into DC. It is the depth. It is the effective depth of the footing at critical section. The effective depth of footing at critical section is 0.2 meter. So in this case, definitely answer will be 260 kilopascal, kilonewton per meter. If I want to write kilopascal, there are no options. Everything was there in megapascal. So 260 kilopascal, I can write as 0.26 megapascal. Is option A itself is the correct option, right? So this is how we can work out the problems in this footings. So for today, I am just ending the session. Tomorrow we will start about this pre-stressed concrete, brothers. Right. So before I end this topic for today, I just want to convey there is so much of free content is already happening in this Unacademy learning. So if you are a serious aspirant of GATE or ESE or any other competitive exam, then definitely I can recommend you guys to take this or to download this Unacademy. And coming to the paid courses, there are 12 months paid course is there, 18 months paid course is there, 24 months paid course is there. To get 10% discount for any of the paid course, to get 10% discount, you are bound to use this code BT10. When you are able to use this code BT10, directly 10% discount will directly come to you on all the courses in Unacademy, plus either from 6th standard to PG standard, any course, right? And you can follow me in Unacademy Learning app by using this link, which is given below. And one more thing, every day my class is happening in this Let's Crack GATE and ESC Civil YouTube channel. My class is happening by 11 a.m. So don't forget to come down to my class. Moreover, this is a rankers batch class, and you can resolve your doubts directly by coming down here. One thing. And I can also recommend Kamalakar Pandey sir classes also to you. Every day his class is happening by 9 a.m. Last but not least, you are getting all this for free of cost from this channel, Let's Crack GATE and ESE. So please subscribe to this channel, and not even a single video you will miss from this channel if you are able to press this bell icon. When you press the bell icon, you will not miss even a single video, and you will get each and every free content that is releasing from this channel. Please like our videos, share our videos. Please raise a thumbs up for our videos. Please share our videos. Please subscribe to our channel, Let's Crack GATE and ESC. Right. And finally, I want to convey you, for you guys, I already started a Telegram group, and the name of the Telegram group is Let's Crack GATE and ESC, and the name of another Telegram channel is Unacademy _ Civil Engineering. You come down to this channel and post your doubts. We'll take care of your doubts directly in this Telegram group. To come down to this Telegram group, use this link which is given below. You press this link, you guys will be redirected to my page of Telegram channel. Right. Thank you. End of the session. Please do subscribe to our channel, and please subscribe to Unacademy Combat also. Thank you.